So this particular discussion aims on sterility testing of parental products. So first is test for sterility of the product to be examined. So the test of sterility can be done by two methods: membrane filtration method and by direct inoculation method. And in both the methods, appropriate negative controls must be included for comparison. Now we'll start with membrane filtration. The technique of membrane filtration is used whenever the nature of the product permits, that is, for filterable aqueous preparations, for alcoholic or oily preparations, and for preparations miscible with or soluble in aqueous or oily solvents, provided these solvents do not have an antimicrobial effect in the conditions of the test. So membrane filtration will be the method of choice for the liquid formulations, either aqueous or alcoholic or oily preparations, uh, so that they get filtered through membrane filter paper, and the microbes will be retained onto the filtration medium, and the product will come down from the filtration medium. So that is the criteria. And when the membrane is incubated in suitable medium, fluid thioglycolate medium or soybean casein digest medium, then they may the filter medium may show the growth of microorganism. If it does shows the growth of microorganism, then the test of sterility fails. If there is no growth of microorganism on the filtration medium, then the test for sterility, the product passes the test for sterility. Okay, so first criteria under membrane filtration is membrane filter selection. So the pore size of the membrane filter which is selected should not be more than 0.45 micrometer, so that it retains the microorganisms onto its surface. Next is cellulose nitrate filters are generally used for aqueous, oily or weakly alcoholic solutions. So where the alcoholic concentration is less than 30% volume by volume. Whereas cellulose acetate filters are used for strongly alcoholic solutions. So where the concentration of alcohol is greater, more than 30% volume by volume approximately. And specially adapted filters may be needed for certain products like for antibiotics. Next is the process itself. So it assumes that the membranes about 50 millimeter in diameter will be used generally. If the membrane of different sizes to be used, then the volume of dilution and washing should be adjusted accordingly. This must be tested in the suitability test that we have already studied in previous lecture. The filtration apparatus and membrane are sterilized by appropriate methods before utilizing into sterility test. And the apparatus is designed so that the solution to be examined can be introduced and filtered under aseptic conditions. So whatever apparatus and membranes are used should be compatible with the aseptic condition for the sterility test. Okay. Next is sterility test for aqueous formulations. So if appropriate, transfer a small quantity of suitable sterile diluent such as 1 gram per liter neutral solution of meat or casein peptone, pH 6.9 to 7.3 onto the membrane in the apparatus and filter. So this sterilized diluent will act as the growth promoter of the microorganisms onto the membrane. The diluent may contain suitable neutralizing substances to inactivate certain antimicrobial agents present into formulations, like in case of antibiotic formulations. Okay. Next is transfer the content of the container to be tested to the membrane if necessary after diluting to the volume used in the method suitability test with the chosen sterile diluent, but in any case using not less than the quantities of the product to be examined prescribed in table 2. So we have a table in the following slides. So that prescribes the minimum quantity of the formulation to be tested for this particular test based upon the total volume of the formulation in a container. Okay. So this particular point says that one can use the content of the entire content of the container if it is appropriate, or if the viscosity or certain other ingredients which may have effect on the sterility test says that it requires dilution, then the formulation can be diluted and can be filtered through the membrane filter. The volume should be fixed into the suitability test prior to running the final test, and this volume after dilution should not be less than the quantity which is prescribed for the container in the table 2 in the following slides. Okay. Next is filter immediately. If the product has antimicrobial properties, wash the membrane not less than 3 times by filtering through it each time the volume of the chosen sterile diluent used in the method suitability test do not exceed a washing cycle of 5 times 100 ml per filter. So this says that if the formulation has certain ingredients or the drug itself is antimicrobial in nature, then after filtering the product, you need to give washings to the filtration medium so that this antimicrobial agent gets washed away and only the microbes get retained onto the filter paper. So this should be for the minimum of 3 times, and it should not exceed 5 times washing cycle, and the volume of the washing fluid must be determined in the suitability test. Next is transfer the whole membrane to the culture medium. So after washing, the entire membrane itself is put into the culture medium, or you can cut the filtration medium into 2 equal halves aseptically and insert one half into one medium, maybe fluid thioglycolate medium, and another half to the another medium, which is soybean casein digest medium. Okay. Use the same volume of each medium as in the method of suitability test. So you are going to use the volume for each fluid thioglycolate and soybean casein digest medium that you used for the suitability test and incubate for not less than 14 days. So here we can consider that the suitability test is the kind of pre-formulation practicals to conduct sterility test for the final products. Okay. Next is if we have soluble solids which are to be reconstituted before administration, then for such formulations use for each medium not less than quantity prescribed in table 2 of the product dissolved in a suitable solvent, such as the solvent provided with the preparations, water for injections, sodium chloride, 9 gram per liter or peptone 1 gram per liter, and proceed with the test as described above for the aqueous solutions. So here the solids will be dissolved in the suitable solvents, and then once the solution is formed, the test for sterility becomes the identical as that of the aqueous formulations. So this is that table. Onto the left hand side, it shows that the container capacity or the content of a container, and the minimum quantity to be used from each container for the testing, for the sterility testing. Whereas on the table onto the right hand side shows that the batch size of the sterile products, and from that particular batch how many containers should be taken as sample and should be tested for sterility test. So these are the two tables, and according to the to this guidelines, the samples are removed and the sterility test is done. So here if it says that 10%, I mean on the right hand side, if we have small volume containers and the volume is not less than, I mean volume is between 101 to 500 ml, sorry 500 units, then minimum 10 containers should be withdrawn for the test. So for each 10 containers, the sterility test will be individual. So every container will be opened aseptically and will be tested for aerobic, anaerobic and fungi microbes. It is not that the 10 containers are taken, all containers are opened aseptically, the content is mixed, and then the sterility test is done. Is not the way. Every individual container is tested separately for aerobic, anaerobic and presence of fungi. Okay, so thus these two tables are the guidelines for how much volume and how many containers must be used for the sterility testing. Okay, so continuing with the membrane filtration, we are done with aqueous solutions. We are done with the solids which are soluble and will form solution in suitable solvent. Now next is oils and oily solutions. So for this, use for each medium not less than the quantity of the product prescribed in table 2. Oils and oily solutions of sufficiently low viscosity may be filtered without dilution through a dry membrane specifically. Whether viscous oils may be diluted as necessary with suitable sterile diluents such as isopropyl myristate, shown not to have antimicrobial activity in the condition of the test. Allow the oil to penetrate through membrane by its own weight and then filter, applying the pressure or suction gradually. Wash the membrane at least 3 times by filtering through it, each time about 100 ml of suitable sterile solution such as peptone containing suitable emulsifying agent at a concentration shown to be appropriate in the method suitability test. And for example, polysorbate 80 at a concentration of 10 gram per liter can be used as emulsifying agent, and transfer the membrane to the culture media as described in aqueous solution. So this says that if oils or oily solutions are to be tested for sterility testing, then if the viscosity is sufficiently low, you can directly filter oils or oily preparations through dry membrane. Or if the formulation is viscous in nature, you can dilute it with appropriate miscible solvent or the diluent, provided that diluent doesn't have its own antimicrobial activity. Then allow the filter to wait, and then the formulations will be filtered by applying positive or negative pressure. Once the filtration is over, washing of filter paper, washing of membrane filter paper is necessary with an emulsifying agent so that all oily traces get washed away, and then after the medium is incubated in the two separate culture. Okay. So that is the procedure for oils and oily solutions, ointments and creams. So you are going to use the quantity as prescribed in table 2, and in ointments in a fatty base and emulsion of water in oil type, you can dilute it with 1% of isopropyl myristate and then heat. The heating should not be at temperature more than 40 degrees Celsius. In certain cases, it can be up to 44 degrees Celsius. So raising in temperature causes reduction in the viscosity, and then filter the formulations immediately after heating, and then the filter paper is treated as prescribed in oily solutions and then incubated. Okay. Next, we'll see direct inoculation of the culture medium. So earlier was the method membrane filtration, and now this is the second method by which you can go for sterility testing. You can use either of the methods. So this second method is direct inoculation of the culture medium. So here aqueous solutions are for soluble solids. Transfer the quantity of the preparation to be examined as prescribed in table 2 directly into the culture medium, so that the volume of the product is not more than 10% of the volume of the medium unless otherwise prescribed. Okay, so you have to take minimum quantity of the formulation as prescribed in table 2, and this will be the 10% of the total culture medium. Okay, and then go further with the incubation. Another case is if the product to be examined has antimicrobial activity, carry out the test after neutralizing this with a suitable neutralizing substances or by dilution in sufficient quantity of the culture medium. If the formulation possesses certain ingredients which are antimicrobial in nature, then prior to sterility test, neutralization of such ingredient is done to render them uh, neutral with respect to the antimicrobial activity, or you can dilute it in sufficient quantity so that its antimicrobial activity becomes insignificant, and then put this formulation into the culture medium and incubate. Next case is when it is necessary to use a large volume of the product. The concentrated medium may be added directly to the product in its container. So in earlier two cases, we are adding product to the culture medium. But with respect to large volume parenterals, where the volume exceeds 100 ml and it can go to liters, in such cases, rather than transferring product to the culture medium, you can make concentrated culture medium, and that you can introduce into the container under the aseptic condition. And then these containers are incubated for sterility testing. Next is oily liquids. Use media to which have been added a suitable emulsifying agent at a concentration shown to be appropriate in the method suitability of the test. And for example, polysorbate 80 at a concentration of 10 gram per liter. So since all culture media are aqueous in nature, oily liquids and ointment and cream will not get miscible with the culture media. And if these are not miscible, the microbial growth may be, the results will be inappropriate. So to make them miscible with the culture media, appropriate emulsifying agent in appropriate concentration is used such that the emulsifying agent doesn't affect the microorganisms which are already present into the formulation or which are to be detected. and then go further with the incubation as explained under aqueous solutions or soluble solids. For ointments, again, you can dilute it by adding emulsifying agent and then put it into the diluted medium not containing any emulsifying agent. So in oily liquids, you can have emulsifying agent into the culture medium, whereas in ointment and cream, you can dilute it with the emulsifying agent and the culture may not contain any emulsifying agent. So the oils, ointments and creams get mixed properly into the culture medium and the result obtained will have appropriate interpretation. So after this, incubate the inoculated media for not less than 14 days. Observe cultures several times during the incubation period. It is not that at the end of 14 days you are going to observe it. Rather, you will observe at pre-specified time intervals within this 14 days of incubation. Then shake cultures containing oily products almost every day. But the formulation which is incorporated into fluid thioglycolate medium should not be disturbed or mixed. This is because mixing will reduce the anaerobic condition. So the growth of anaerobic microorganism will be suppressed. So soybean casein digest medium should be gently mixed every day where it contains oily formulations or ointments and creams, but the fluid thioglycolate medium should not be disturbed, otherwise the anaerobic condition will be interrupted and this results into poor growth of anaerobic microorganisms. Okay, next is observation and interpretation of results. So at intervals during the incubation period and at its end, they examine the media for macroscopic evidences of the microbial growth. So during this 14 days interval of, time period of incubation, and at the end of 14th day, the media is observed or visualized for the colonies which are formed by the microorganisms. If the material being tested rendered the medium turbid, so that the presence or absence of microbial growth cannot be readily determined by visual inspection, 14 days after the beginning of the incubation, transfer portions not less than 1 ml of the medium to the fresh vessel of the same medium, then incubate and then observe for the growth. So if the formulation or the mix of culture and the formulation is turbid and that doesn't provide visual inspection for the growth of microorganisms, then after 14th day of the incubation, small portions are removed and mixed into the vessels containing only the culture medium, and then these are further incubated for 4 days and inspected for the growth of microorganisms. Next is, if no evidence of microbial growth is found, that is no microbial colony is found, the product to be examined complies with the test of sterility. That is, it says that the tested samples are sterile. If evidence of microbial growth is found, the product to be examined does not comply with the test for sterility. Okay, if microbial growth is found, that says that the samples withdrawn are non-sterile in nature, it contains microbial organisms, unless it can be clearly demonstrated that the test was invalid. That is, if it says that due to one of the following reasons which are listed as A, B, C, D, this fault occurred during the testing and so the test is invalid, uh, then you cannot conclude whether the sample were non-sterile or it was due to the fault in the test, and you have to, one has to repeat the test for sterility. Okay, so these conditions are the data of the microbiological monitoring of the sterility testing facility shows a fault. कि जो भी protocol है that protocol is only faulty, or a review of the testing procedure used during the test in question reveals a fault. Okay, so when the monitoring is done for the procedure, it was found that something has gone wrong during the procedure, or the microbial growth is found in the negative controls as well, or after determination of the identity of the microorganism isolated from the test, the growth of this species or this species may be ascribed unequivocally to fault with respect to the material and or the technique used in the conducting the sterility test. This says that the after conducting the test, if the microbial growth is found and the microorganisms are isolated and further they are grown and tested for chemically and microbiologically tested to identify the species of the microorganisms which are found in the test. And if it is found that this microorganisms cannot be there in the samples, because every material will have specific bioburden. So अगर ये उसमें हो ही नहीं सकता, ये microbe to test accidentally, then in such cases, the test procedure is faulty and now the sterility of the product is in question. So the sterility test must be repeated to confirm that whether the formulation is sterile or it has microbial contamination. So this is all regarding what you can say sterility testing of